class, we are going to learn about probability distributions. Having learned expectation and mean, variance of various distributions, here we are going to learn some special type of distributions called discrete and continuous. Discrete, by the name itself, it says about number of persons, products, like that way. So under this head, we are going to learn about binomial and Poisson. Continuous distribution, there are many. We are going to concentrate only on normal distribution. Binomial, today's topic. The name itself suggests bi means two. So this distribution mainly concentrates when there are two possible outcomes, say success or failure. Success. For example, if I toss a coin, I may get either a head or a tail. So if I declare getting a head is a success, I may either get success or I may get failure. So success I term as P, failure I term as Q, and P plus Q is always 1, the basic concept of binomial distribution. So let us see in detail with all the examples the main concept. Exercise 7.1, question number 2. Define Bernoulli's trials. Binomial distribution is based on Bernoulli's trials. So what is Bernoulli's trial? It is a random experiment which has only two possible outcomes. And what are the two possible outcomes? Success or failure. So whenever I toss a coin and if I declare getting a head is a success, if head comes, it is a success. If head doesn't come, it is a failure. So there are only two possible outcomes. So to put it apt, a random experiment which has only two possible outcomes, say success or failure, is called a Bernoulli's trial. P, probability of success, and Q, probability of failure. Example, tossing a coin. Now define a binomial distribution. Question number 1. A random variable x follows binomial with parameters n and p. What is this n? How many times I toss the coin? So n is number of trials. Then what is p? Probability of success. Then I must know what is the probability of failure. Call it q. What is this q? 1 minus p, which is probability of failure. Supposing I toss a coin 10 times. I should tell I want 5 heads, 4 heads, minimum 3 heads, maximum 4 heads. So what I declare is called x. X is the number of successes. Now what is the distribution? P of x is equal to x is equal to ncx p power x q power n minus x. X is a non-negative value starting from 0 till n. And it is 0 otherwise. Exercise 7.1, question number 3. Derive mean and variance of a binomial distribution. Mean, how do we call that? Mean is nothing but expectation of x. What is expectation of x formula? It is sigma x into p of x. Sigma x into. What is p of x for a binomial distribution? It is ncx p power x q power n minus x. Now, whenever this ncx is coming, I must remember a formula. ncx can be rewritten as n by x into n minus 1 cx minus 1. This n by x into minus 1 in each thing. N minus 1 cx minus 1. So this is combination formula. The next case, let me substitute that here. ncx I am writing n by x, n minus 1 cx minus 1. P power. This x and x will get cancelled. Because x minus 1 is coming, P power also, I want x minus 1. Whenever I put minus 1, I also put plus 1. Q power n minus x. Now, here actually I say 0 to n. But because x is coming in the denominator, I must rewrite it as 1 to n. Now, this n I can bring outside the sigma. Also, p power 1, let me bring outside sigma. What is remaining? N I have taken, p power 1 I have taken. What is remaining? N minus 1, c x minus 1, p power x minus 1, q power n minus x. Now, it is valid only if I put from 1. Why? Because 0 if I put, 0 minus 1 will be negative. I can write only non-negative values. So, because x minus 1 is coming, sigma rearranged as 1 to n, not from 0 to n. The next step. This is nothing but q plus p the whole power n. We write this from binomial expansion what we studied in standard 11. So, n minus 1 c x minus 1, p power x minus 1, q power n minus x is reduced as q plus p the whole power. Here what is coming? N minus 1. So, I write n minus 1. But what is p plus q? In a binomial distribution, p plus q is 1. So, use this formula and this will become 1 power n minus 1, that is 1. So, I write np into 1, which is nothing but np. So, we have derived the mean of the binomial distribution, which is np. As we see the steps again, binomial distribution formula, p of x is equal to x is ncx, p power x, q power n minus x. We need to find mean. Mean is nothing but E of x. E of x is rewritten as sigma x into p of x, what we studied in the previous chapter. X as it is, p of x I copy from here. Ncx, because this x is coming which I need to cancel, we rewrite ncx using this formula. It is n by x, n minus 1c x minus 1. As I substitute, x and x gets cancelled, take n out. P, because it is power x, I want n minus 1. So, x minus 1. So, from x, subtract 1, add 1. This p power 1 is taken out. The remaining reduces as q plus p the whole power this number. Now, remember, whenever I put x minus 1, I should not put 0 to n. It is invalid. X minus 1 should start from 1. Then only 1 minus 1 will be 0. So, do not put 0 to n. The moment you write x minus 1, rearrange x values from 1 to n. So, this full expression reduces as q plus p power n minus 1, but p plus q is 1. So, 1 power n minus 1 is 1. So, forget this. My answer is np. I want to proceed with e of x square. What is e of x square? Sigma, the same pattern, x square p of x. X square. What is p of x from the question? ncx, p power x, q power n minus x. How should I proceed? Sigma, x square is coming. How to write this ncx? See, ncx I can write n by x, n minus 1c, x minus 1. First step. But I want x square here. So, write one more term. N by x, write once again this number by this number. So, n minus 1 by x minus 1. What is the next term I write? N minus 2, c, x minus 2. The next step, we substitute this here. Because x and x minus 1 is coming, How to write this x square? Subtract x and add x. It doesn't get disturbed. I am just subtracting x and I am adding x into this ncx from here. It is n by x, n minus 1 by x minus 1, n minus 2 cx minus 2. The next step we try to simplify. Combine these two terms which I can write x into x minus 1. What is remaining? N by x, n minus 1 by x minus 1, n minus 2c x minus 2 plus what is the next term? X. When I write x, write the original term itself. This x square, I write minus x plus x. With minus x, we'll write this expanded model. With plus x, you write the original function itself. That is x into ncx p power x q power n minus x. This full thing, as I read from here, reduces to np. So this second idea gives rise to np. This first idea I have to simplify. How do I simplify? X and x minus 1 will get cancelled. I am left with sigma. N minus 1 also I can bring outside. What is left out? N minus 2 C x minus 2. Because x minus 2 is coming, the problem should start from 2 to n. Here also, whenever I put n minus 2, start from 2 to n. The next step, p power x q power n minus x, let us write as it is. Because x minus 2 is coming, I want x minus 2 only for p also. So this power x, subtract 2 and add 2. The next term, q power n minus x, the full second term becomes np. The very next step, n minus 1. P power 2 I don't want here. I want only x minus 2. So keep p power x minus 2 inside. P power 2 will come outside. Then what is left here? Sigma 2 to n minus 2 c x minus 2 p power x minus 2 q power n minus x. The second term np as it is. Now this full idea will become, according to the formula, q plus p the whole power n minus 2. So this I shall multiply n into n square, n into 1 n into p square, and this full thing reduces to q plus p the whole power n minus 2 plus np. Q plus p is 1. 1 power any number is 1 only. Forget it. So what is left out? N square p square minus np square plus np. The next step, I want to find out variance. This is E of x square. What is variance formula actually? Variance is nothing but E of x square minus E of x the whole square. What is E of x square? This full answer. N square p square minus np square plus np minus. What is E of x the whole square? E of x we derived as np. So it is n square p square. Cancel. What is left out? In these two terms, np is common. Take it out. This is minus p plus 1. We know p plus q is 1. So what is q? 1 minus p. Using this formula here, n, p, 1 minus p is nothing but q. So we have derived variance equal to npq. Mean, already we derived the answer, that is np. This is an important 5-mark question. Let us see the full problem once again. E of x square is sigma x square p of x. That is sigma x square. P of x is ncx p power x q power n minus x. Now x square is coming. This ncx, see how we have rewritten? Ncx can be written as very first step n by x, n minus 1 c x minus 1. The next step n minus 1 c x minus 1, I can further write n minus 1 by x minus 1, then subtract 1, n minus 2 c x minus 2. This is another notation of writing this combination. I can write n minus 1 c x minus 1 like this, or in bracket one below the other. Both are combination notation only. Now coming back here with x square, subtract x, add x. So when I subtract, combining x is common into x minus 1. So this term into this full expression plus x into. So we multiply like this. First bracket into the outside term, x into the outside term. We know this full thing becomes np from this step. So the second part becomes np. Concentrate in the first part. X square minus x. I can write x into x minus 1. Because here x into x minus 1 is coming, this ncx, we rewrite like this pattern. So which is n by x, n minus 1 by x minus 1 into n minus 2 c x minus 2. P power. Because x minus 2 is coming, subtract 2, add 2 in p. And whenever I write like this, the sigma ranges from 2 to n, because it is valid only if this starts from 0. I cannot give negative number here. So because x minus 2 is coming, sigma starts from 2 and ends with n. The very next step, x minus 1 and all will get cancelled. N minus 1 I can bring out. P power x minus 2 I want. So p power 2 also comes out. Then what remains? I have taken this 2 cancelled. I have taken n minus 1. I have taken p power 2 also. Then what remains? N minus 2 c x minus 2, p power x minus 2, q power n minus x. This full thing becomes q plus p the whole power n minus 2. Here I said q plus p the whole power n minus 1. But whatever may be the power, p plus q is 1. 1 power, this number is again 1. So forget this. I am left with n minus 1 p square. How to multiply? N into n into 1 into p square plus np. So this is the answer for E of x square. Let me proceed with variance. The formula is E of x square minus E of x the whole square. This is E of x square. E of x is np. So np the whole square. Cancelling the 2. Taking np out, it is 1 minus p, which becomes q. So variance is npq. Let us tabulate the two answers. Mean is np and variance is npq. Exercise 7.1, question number 4. Write down the conditions for which binomial distribution can be used. Now what is the binomial distribution we had learnt? ncx, p power x, q power n minus x. Say the conditions related to this. N, I must say toss a coin 10 times, 20 times, 30 times. So n must be finite. The very first idea. Second, first time whether head comes or not does not depend on second time, does not depend on third time, and so on. So the trials are independent of each other. The next, probability. First time or second time or third time, head probability is 1 by 2. Tail probability is 1 by 2. Similarly, if I throw a die, getting 4, the probability is 1 by 6 every time, because 1 4 only is there in the die. So the probability of success is constant for each trial. You cannot be changing the probability for next trials. If I toss a coin, I can immediately say getting ahead is always half only. So probability of success, that is P, should be a constant for each trial. Fourth condition, in every trial, there are only two possible outcomes, success or failure. For example, if I toss a coin, either head should come or tail should come. So, success or failure, only two possible outcomes. So, what are the key words that I have to remember? N finite. Trials are independent. P is constant and only two possible outcomes. So these are the conditions for a binomial distribution. Question number 5. Properties of binomial distribution. As I say the properties of binomial distribution, number 1, the binomial distribution is symmetrical if P and Q are equal to 0.5. That is equal probability for success and failure. It is Q symmetric if it is not equal. Positively skewed if P is below 0.5 and negatively skewed if P is above 0.5. See, we have seen curves like this. A regular increase and a regular decrease. This is a curve which I can say symmetrical. But there are curves like this. Here it is very less and sudden peak. Here it is a peak and sudden decrease. So this we call positively skewed and this we call negatively skewed. So binomial has these conditions. Symmetrical when P and Q are equal to 0.5. Positively skewed when P is below 0.5 and negatively skewed if P is above 0.5. The mean, as we discussed earlier, it is NP and the variance is NPQ. Now tell me which is bigger, NP or NPQ? This is product of two terms, this is product of three terms, but still NP is only bigger because Q is a number which is below 1. Q is a number which is below 1. So, NP is greater than NPQ. See, N may be 20, Q may be, let me say, 1 by 4. What is N? It is 20. What is P? It is 1 by 4. So, what is Q? 1 minus 1 by 4. That is 3 by 4. Tell me which is bigger. Here I cancel. My answer is 5. Here I cancel. It is 15 by 4. This is 5. This is 15 by 4 and obviously I see this is bigger. Remember, it is the most important property of binomial distribution that mean is greater than variance, or in other words, variance is less than mean. So properties of binomial, we highlight these things. This is the most important. Variance is less than mean. Symmetrical if P and Q are equal to 0.5. Skew symmetric if they are not equal. Positively skewed if P is below 0.5 and negatively skewed if P is above 0.5.